Hey guys, so in this video we're going to have a look at equations with matrices. So the way we're going to start this off is if we have an equation which has two coefficients, so we might have an equation which has an a times by this x. So I'm going to use my a as my coefficient in this case, and x is this variable that we're interested in. And then we can also have, say, some number, we'll call it b, and we can multiply that by our second coefficient y. So we've got this equation which has these two coefficients here, so these are our two coefficients. We've got x and y. So sorry, these are our two variables, not coefficients. So these are our two variables. And then we have these two coefficients. So we have these two coefficients. And this is our a and our b. And we can set these equal to, say, some constant, and we'll call that constant c. So it's a constant number. So what we want to do is we want to have a look at, firstly, can we express this as a set of matrices, just to make it easier. So you might be wondering why we're going to do it. It's not that clear when we only have this one equation, but if we had a system of, say, 15 or 20 equations, then it would be more useful to us. But for our purposes, we're just going to use this one equation to start with, and then we're going to look at an example where we have two equations. So we'd start by saying, okay, we have a times x plus b times y. Is there a way that we could write these using matrices that would allow us to write this equation in a form something like this down here? And it turns out that there is a way that we can do it. So what we do is we take the coefficients of our equation and we write them in. So we take our coefficients and we write them into this row vector here. So we put the coefficients into this row vector. So we say we have the coefficient a on our x, and then we have this coefficient b, and we also put the coefficient b into our row vector. And then we just take our variables and we put them into a column vector. So our variables here come down into this column vector, and we just write them. X, our first variable, goes in, and then y, our second variable, goes in. And that's how we write an equation with a matrix. So we just say our coefficients go into a row vector and our variables go into a column vector. And then we just let all of that equal to this constant which we had before, and that constant is equal to c. So we've seen a row and a column vector before, and we can kind of look at why we can do this. So we've done a little bit of matrix math before, and we said if we had two vectors, they were of this R by C. So two matrices, they're of this R by C order, and if they're of this order, then we can multiply them together if we had one condition. So if we look at this row matrix here, we're going to say that has one row, so one row which goes from left to right, and one column which is here. So it's got one row and two columns. And then if we look at this column vector, we can say that's got two rows and that's got one column just down. So we said because these two numbers are the same, we can go ahead and multiply that matrix, and it's going to give us a constant. So what we're going to do is we're just going to multiply this matrix now. So if we go ahead and multiply that, what we're going to see is when we complete this multiplication, we're going to get a multiplied by x, so that's going to be our first term. So a multiplied by x, so we take the first term in the first column in the first row, and then we multiply it by that first term in our first column in our second matrix. Then we're going to add to that b multiplied by y. B times y. So you can see that if we take these two matrices and just multiply them together, we end up with that equation that we started with. So in order to transform equations into matrices, you take the coefficients, you put them into a row, and then you take the variables and you put them into a column. So that's kind of looking at it with just one equation. But what we can do is we can look at it with a set of, say, two equations. So I'll get rid of all that. So say we have a times x and then we've got this b times y, and that's equal to c. And then we've got d times x, and we've got e times y, and we let that equal to, let's say, f. So we've got these two equations. We've got a times x plus b times y equals c, and d times x plus e times y equals f. And we want to write these equations with matrices. So we said before that these are going to be our variables. So these here are our variables. And these things out the front here, so the a and the d, and then the b and the e, the b and the e are our coefficients. And we said that we can take our coefficients and we can put them into a row vector, and we can take our variables and put them into a column vector. But if we look here, we're going to have more than one row of coefficients. So we take our a and b and we put it in just as we did before, but then this time we also put in our d and our e. So we put in our d and our a and b and our d and e, just like that. We just take them and we slot them in. So a and d, b and e. And then we said we can take our other variables and we can write them into a column matrix. So we can just draw up a column here, and in that column we can put our x variable, and then we can also put our y variable, and then we just set it equal to exactly what it equals to over here. But this time, rather than just having it equal to one thing, it's going to equal to c and f. So we can just take them and we can put them down here in a column vector. And that's going to be the way that we represent these two sets of equations here. So if we actually then go ahead and do what we did last time and we just multiply them out, we can start with the top row. So if we start multiplying across the top row, we're going to get a multiplied by x. So we're going to have a times x. This is just vector multiplication that we've looked at before. And then we have our b times our y. So we add to that our b times y. And then we also have a second row. So then we start multiplying our second row. We have d times x. So we take our d, multiply it by our x, d times x, and then we take our e times our y. And you can see that if we just multiply these two matrices together, we end up with the equations we started with: a times x plus b times y, d times x plus e times y, and it's equal to c and f. So that's how we write out equations with matrices. It's going to be quite useful in another video when we are going to use these equations to actually solve systems of linear equations. So we could solve out for x and y. And we're going to have a look at how to do that in another video, so I look forward to seeing you guys then. Thanks.